So in this video we're going to be talking about solvent extractions. So solvent extraction is a purification technique used to separate one component from another or many components. So generally it's the extraction of a compound, normally a product, from a reaction mixture as a solution into a second extracting solvent. The fundamental idea is that we take the reaction mixture, remove the product or remove the impurities, and leave a solution with mainly just the product that we can then go on to use and purify further or analyse. This purification requires the knowledge of partition coefficients and knowing which solvent your product is going to prefer to go into, and you need to understand miscibility and how to choose which solvent is going to be appropriate for your extraction. So for this demonstration we've got a mock-up reaction mix here where we have, in an organic solvent, ethyl acetate, we've done a reaction which has produced a water-soluble product which is blue in colour. So you can see the reaction mix. We've got a lot of the product at the bottom, and which is water-soluble, so it doesn't really want to become mixed with the ethyl acetate at this point. And we've got the ethyl acetate as the bulk of the liquid, which has a slight blue coloration into it, where some of the product has dissolved into the ethyl acetate. So what we're going to be doing is we're going to be extracting our product using water from the ethyl acetate, so that hopefully the ethyl acetate should end up being effectively colourless because we've taken all the product out of it, and we should end up with a set of aqueous layers or aqueous portions which we can combine, which should be blue with our product in them. So the first thing to do with your separating funnel, check that the tap is closed, because you don't want to pour it in and have it all come straight out the bottom. So check that the tap is closed first and foremost, and then secondly you want to put something underneath just in case your tap leaks, right? So just in case it goes wrong, we've still got our product, because this reaction may have taken hours. So we're going to get our funnel, if we've got one, and we're just going to pour all of our reaction mixture into our separating funnel, like so. And you can rinse this out with some solvent if you need to, but I'm not going to for this because I'm not bothered about the yield. So that's going to go to the back. And take the funnel out. It's conveniently grabbed my stirrer bar from the reaction. And so we've got our separating funnel. So we've only really got one layer at the moment. The reason it's bulking up at the bottom is because our product doesn't want to be in the ethyl acetate. So what we're going to do is we're going to extract 3 times with 25 ml of water. So what I'm going to do is I'm going to wet measure out 25 ml of water. It doesn't need to be accurate, it's not an exact science. So there's about 25. I'm going to put that into my separating funnel. There we go. And you should see that now we're starting to get 2 layers form. Right, so we're going to find the stopper it, invert, with my little finger I'm going to hold the flask lid on, invert it, and vent it. You'll hear it hiss. So it's good practice to, as soon as you inverted it, to vent it. And then going to shake it around, swirl it around, and vent. You want to do this about 5-6 times. And you don't want to be holding it unvented for more than about 5 seconds at a time, because depending on the combination of reagents you've got in here, you can form a lot of gas, especially if the solution is still warm from your reaction. So you want to have this vented as much as possible and vent it in a safe direction. So I'm happy with that. So once you're done with it, close the tap, place it back into your separating funnel ring, and take the bung out the top. Okay? Right. So the next part is running through the layers. So you need to know which layer you need to collect. So I know that my ethyl acetate has a density of about 0.9 grams per mil, and water has a density of about 1 gram per mil. So because of that, the most dense one is going to be on the bottom, so my bottom layer should be the water layer. So the water layer should have my product in. So what I'm going to do is I'm going to get a conical flask, because that's what I'm choosing to use. I'm going to write on it aqueous, in brackets, product. Make sure you label your conical flasks or your beakers or whatever you use to collect your layers in, because it can get very complicated very quickly especially when they're not a coloured solution. So I'm going to take my conical flask. I'm going to make sure the bung is out. I'm going to run through the aqueous layer into my conical flask. There we go, like that. I'm going to stop a little bit short as well because I know I'm doing further 2 more extractions. So there's my first aqueous layer, and you can see how it's very blue because it's got all the blue product in it now, which wants to be in the aqueous layer. If we look back, this should now just be ethyl acetate layer, and it's still got a blue tint to it. It's still got some product in there that's happy to coordinate with the solvent very slightly. But I want to get all that out. There may be about 5% product in there. So back under just in case, and another 25 ml of water. If you read through the lab guide, you'll see that we explain the importance of using lots of little portions as opposed to one bigger portion. It's to do with concentration gradients. So that's going to go in, and then same as before, bung in, pull out, grab it, shake and vent. And the bung out. I'm going to let that settle. Sometimes you may struggle to get the layers to separate. If you've got a lot of product in there, the product can work as a kind of surfactant and hold the layers together and form what looks like an emulsion. To break that down, you can just add more of one or both of your solvents. So I'm extracting with 3 times 25, but it's perfectly fine to just add more water in if I need to. Or if I'm not sure which layer is which, I can add more of the one solvent and see which layer it goes into. So that's separated out quite nicely. So I'm going to collect this into a different beaker just because I'm going to do aqueous product 2. I'm going to collect this into here now, making sure the bung is out, otherwise it won't come through. There we go. You can see it's a little bit paler blue, but we're still getting product out. And the ethyl acetate layer has lost a bit more of its colouring. So, waste underneath. Final 25 ml of extracting solvent, so this is the water. It's common that you'll be extracting with an organic solvent from an aqueous reaction mixture as well, so it works both ways. Chuck that in. Bung in and shake. And remember to vent. Don't have it closed, start talking to someone and not vent it, because it'll either push, the likelihood is that it will push the bung out on your finger and it will all come down your arm. And it does happen. There we go, so closed, back into the ring, bung out. I'm going to collect this one into the second fraction because I'm confident it's the same, effectively the same components. So I'm just going to let it settle out, see how the cloudiness is disappearing as the layers separate. And run it through. Now you don't want to get any of the ethyl acetate layer through, especially on this final one, because it's going to have impurities. So I'm going to stop a little bit short, like that. So now you can see we've got our 2 aqueous product layers and our organic reaction mix layer, where we've got very tiny amount of blue coloration left in our organic layer, so taking mostly all of the product out, and then very blue product aqueous layers, which I'm going to combine because I'm happy that they're the same, to one blue product layer. Extracted all our product from the reaction mixture into an aqueous layer, into an aqueous, water solvent, ready to work with next. And our ethyl acetate should hopefully just have impurities left in it. At this point, yeah, that'll do.